Yeah, let's go straight to the work. We are looking at geometric sequence and series. Okay, let's look at the difference between sequence, geometric sequence, and geometric series. Okay, in geometric sequence, we are going to have, for example, let's say we have 12, 24, 24, uh, 24, 48, 96, and so on and so forth. Okay, you can see the number is what is in geometric form, is doubling itself. The first one is 12. The second one is times 2. Okay, that's 24. The third one also is also what? Times what? Times 2. Times 2. Times 2. Okay, and then the sequence is separated by comma. Okay, the first written number is what? It's called the first 10. The second written number, which is 24, is called the second 10. The third written number is called third 10, and then the fourth written number is called the fourth 10. Okay. Then, if you look at series, in series, it's the same thing, but the sequence must be in addition form. 12 plus 24 plus 48 plus what? Plus 96. Okay, the sequence is in geometric, but in addition form. Why in sequence is in comma formats. Okay, the first 10 is a what? Is A1. The second 10 is A2. The third 10 is A3. The fourth 10 is A4. Another thing we can note is a sequence could be finite or infinite. So let's look at that. Finite sequence, okay, has an end. Finite sequence has an end. For example, 12, 24, 48, 96 times 2 again, 96 times 2, 192. Okay, that's as an end. So this is what? This is a finite sequence. It has an end. That's a finite sequence. Infinite does not have an end. The sequence continue to infinity. We don't know the end of that sequence. That is the meaning of infinite sequence. How do we know a sequence is geometric? How? Okay, please, as you are coming in, just begin to type I. As you are coming in, just say I. And then invite your friends. Geometric. Text for geometric sequence or series. Text for geometric sequence or series. Let's play with this number 12, 24, 40, 48, 96, 192. Okay, this is a infinite sequence. Okay, you can also have 6 here. If you want to know whether a sequence or series is geometric, the first thing you have to know, this is what we call the A1, as I've said. That's the first written number, the first 10. This is the second 10, which is A2. This is the third one, A3. This is the fourth one, A4. This is the fifth one, A5. This is the sixth one, A6. That's the sixth term. So if you want to know, if you want to test for geometric, it's very simple. That's what we call the common ratio. Your common ratio is what we use to test for a sequence or series is geometric. Okay, it's going to be HU over A1, HU over A1, which must equal to A3 over HU, which must also equal to A4 over A3, which must also equal to A5 over A4, and so on and so forth. Once it is equal, then once those values are constant, that confirms the sequence is what? Either the sequence or the series is geometric series. Is geometric in nature. When these values are constant, are uniform, then it is called common ratio. R is called common ratio. R is called common ratio. Then such a sequence or series is called geometric. Okay, in arithmetic progression or series, in arithmetic we use common difference. Okay, which is the second term minus first term, which must equal to third term minus second term, and so on and so forth. Okay, we've already discussed arithmetic progression and series. If you missed that video, please check my channel for that. So that's how to test for geometric series or sequence. The next thing to do now is to look at questions. Look at the question we have here. Which of the following are geometric sequence? Which of the following? For the one that are, give the value. Okay, for those ones that are geometric, then give their value. The first one, we have 1, 2, 4, 8, 16, 32. This one is the A1. This first one is first term. This one is second term. This one is the third term. This one is the fourth term. That's A4. This is the fifth. This is the sixth term. Okay. This will be equal to the common ratio is what we use to determine whether a series or sequence is geometric. So that's the common ratio. That's what we use, which will be HU over A1, which is what? 2. And this must also equal to what? A3 over A2, which is what? Which is also what? 4 over 2. Also 2. Which must also equal to what? A4 over A3, which is also what? 2. And so on and so forth. So this confirms the sequence is what? Is geometric. The sequence is geometric. So this one is what? Geometric. The second one, we have 2, 5, 8, 11, 14. Okay? If you look at the sequence, it's not. If you do your HU, second one, B, common ratio, 5 over 2, the second time over first time is not equal to 8 over 5. They're not equal. So this is not the B part, not what? Not geometric. It's not geometric. It's not geometric. Okay? The C part also is, if you look at the sequence for the C parts, we have 40, 36, 32, 28. Okay? If you look at the sequence, it's decreasing by 4. This is decreasing by what? Minus 4. The first time minus 4 will give you the second 10. Minus 4 also, you get the third 10. This is what? Minus 4 also, you get the fourth 10. Okay, this one is not geometric. This is what? This is arithmetic. This is not geometric. This is arithmetic series sequence. Not what? Not geometric. Not geometric. Is arithmetic. Okay, is that clear? The D parts, we have 2, 6, 18, 54, 162. Okay, if you want to know whether a sequence is geometric, you need to get the common ratio, which has the symbol of R. Okay, and that will be A2 over A1, which must equal to A3 over A2, and so on and so forth. And that will be equal to what? 6 over 2, which is what? Which is 3. Okay, which must also equal to what? 18 over 6, also 3. So this is what? This is a geometric. This D part is a geometric. Okay,